Hi, dear friend, you've found a quiet place to rest and dream. Tonight we'll drift together through the gentle wonders of our solar system, that cosmic neighborhood we call home. You don't need to do anything right now. You don't need to remember every detail or hold on to every word. All you need to do is let yourself settle into this moment, into this quiet space where the day finally releases its grip on your shoulders. Let your body sink a little deeper into wherever you're resting. Feel the weight of your head against the pillow, the soft give of the mattress beneath you, the way gravity itself seems to cradle you here on this blue planet spinning silently through the dark. Take a slow breath in, hold it gently for just and let it go, like releasing a balloon into a calm sky. Do that once more, breathing in the quiet, breathing out the day. Tonight's journey is special because we're not traveling to distant galaxies or alien worlds light years away. We're staying close to home. We're exploring the 8 worlds and countless moons and mysterious objects that share our corner of space, all bound together by the gentle pull of a star we call the sun. These are places we've sent machines to visit, worlds we've photographed and studied, landscapes both familiar and utterly strange. And as we wander through them together, you might find yourself drifting, your thoughts growing softer, your breathing slower, and that's exactly what sleep is always welcome here. Our solar system is a story written in stone and ice, in storms that rage for centuries and rivers that flowed billions of years ago. It's a family portrait of worlds, each one shaped by the same ancient cloud of dust and gas, yet each one utterly unique. And you, resting here tonight, you're made of the same elements that form these planets. The calcium in your bones was forged in dying stars. The iron in your blood once drifted through the cosmic nursery that became our sun. You belong to this system as much as Jupiter or Mars or the smallest grain of dust in Saturn's rings. So let's begin. Let's start where all journeys in the solar system must start, at the brilliant heart that holds everything together. The sun is not a planet, of course, but it is the reason planets exist at all. It contains 99.8% of all the mass in the solar system. Everything else, all the planets and moons and asteroids and comets, all of it together makes up less than 0.2%. The sun is vast beyond easy comprehension. You could fit 1 million Earths inside it. 1 million copies of every mountain and ocean and forest, every city and desert and ice sheet, all tucked inside that glowing sphere. But the sun is also gentle in its way. It gives without asking anything in return. Every second it converts millions of tons of hydrogen into helium through nuclear fusion, and in that process, it releases energy. That energy radiates outward in all directions, a flood of light and warmth that takes 8 minutes to cross the void and touch your face on a summer afternoon. Right now, as you rest in the dark, the sun is still shining somewhere on Earth, still warming oceans, still feeding forests with light, still painting the sky in shades of gold and rose. The sun has been doing this for 4.5 billion years. It will continue for another 5 billion more. That's a kind of patience we can barely imagine. The sun doesn't hurry, it doesn't worry. It simply burns, steady and constant, a lighthouse, cosmic dark. And closest to that burning lighthouse, we find the smallest of the classical planets, a world of extremes and contradictions. Mercury is a tiny gray sphere, barely larger than our moon, racing around the sun at 47 kilometers per second. It completes an orbit in just 88 Earth days. But here's something strange and beautiful. Mercury rotates so slowly on its axis that a single day on Mercury, one full rotation, takes 59 Earth days. This creates a curious dance. Mercury spins 3 times for every 2 times it circles. The result is that from Mercury's surface, if you could stand there, you would see the sun rise, climb halfway up the sky, stop, move backward toward the horizon, then reverse course again and continue rising. A single day-night cycle on Mercury lasts 176 Earth days. Imagine a dawn that takes months to arrive. The surface of Mercury is scarred and ancient, cratered by billions of years of asteroid impacts. There is no atmosphere to burn up incoming rocks, no weather to erode the scars. One of the largest craters, called Caloris Basin, stretches nearly 1,000 miles across. The impact that created it was so violent that it sent shock waves through the entire planet, and on the exact opposite side of Mercury, the ground rippled and buckled into strange, chaotic terrain, as if the planet itself shuddered from the blow. During the day, Mercury's surface bakes at temperatures reaching 430 degrees Celsius, hot enough to melt lead. At night, with no atmosphere to hold the warmth, temperatures plummet to minus 180 degrees Celsius. Yet somehow, incredibly, there is water ice on Mercury. In the deep shadows of craters near the poles, places where sunlight never reaches, ice has survived for perhaps billions of years, hidden in eternal darkness on a world that seems to burn. Mercury doesn't ask for your attention. It's easy to overlook this small, swift planet hugging the sun. But it endures, it survives, and there's something quietly inspiring in that. Let your breathing settle into an easy rhythm. There's no rush to this journey. The planets aren't going anywhere. They'll keep spinning long after your eyes grow heavy, long after sleep finds you. Next comes Venus, the brightest jewel in our sky, the morning star and evening star, the planet poets have written about for thousands of years. Venus is nearly the same size as Earth. For a long time, people imagined it might be a sister world, perhaps covered in oceans or jungles hidden beneath those brilliant white clouds. But when spacecraft finally pierced the clouds and measured what lay below, they found something else entirely. Venus is the hottest planet in the solar system, even hotter than Mercury, despite being nearly twice as far from the Sun. The surface temperature averages 470 degrees Celsius, hot enough to melt zinc. The atmospheric pressure at the surface is 90 times that of Earth, the equivalent of being a kilometer underwater in our oceans. And the reason for this hellish environment is the atmosphere itself. Venus is wrapped in a thick blanket of carbon dioxide, with clouds of sulfuric acid drifting high above the surface. This creates a runaway greenhouse effect, trapping heat so efficiently that the temperature never drops, not at night, not at the poles, not anywhere on the entire planet. Venus is a cautionary tale written in the language of chemistry and climate, a reminder that atmospheres matter, that small differences in composition can transform a world. Yet there are wonders on Venus too. The planet rotates backward compared to most others, and it rotates incredibly slowly. A day on Venus lasts 243 Earth days, longer than its year of 225 Earth days. The sun rises in the west and sets in the east, if you could ever see it through those eternal clouds. High in the atmosphere, winds scream around the planet at 300 kilometers per hour, circling Venus in just 4 Earth days, creating a phenomenon called superrotation that scientists are still working to fully understand. And on the surface, beneath the crushing pressure and searing heat, there are mountains taller than Everest, vast volcanic plains, and features that look like they might have been shaped by flowing lava just yesterday in geological. Some scientists think Venus might still be volcanically active, that somewhere beneath those clouds, the planet is still reshaping itself. Venus reminds us that beauty can be dangerous, that brightness can conceal harsh truths, but it also reminds us that every world has its own story, its own strange logic, its own kind of magnificence. Your eyelids are growing heavier now. That's good. That's natural. You can close your eyes and still see these worlds in your mind. You can drift and dream while the story continues. And then we come home. We come to Earth. Earth is the third planet, 93 million miles from the Sun, orbiting in what scientists call the habitable zone, that region where temperatures allow liquid water to exist on the surface. But calling Earth habitable feels almost absurd in its understatement. Earth isn't just habitable. It's an explosion of life, a riot of color and sound and movement, a planet where organisms have colonized nearly every available space, from the deepest ocean trenches to the highest mountain peaks, from boiling hot springs to the frozen interior of Antarctic rocks. Earth has oceans that cover 70% of its surface. It has an atmosphere rich in nitrogen and oxygen, with just enough carbon dioxide to keep things warm, but not so much that we become another Venus. It has a magnetic field generated by a molten iron core, a field that shields us from the solar wind and cosmic radiation that creates the shimmering auroras near the poles. It has plate tectonics, the slow drift and collision of continental plates that builds mountains and opens oceans and recycles the crust over millions of years. And Earth has a moon. Our moon is unusually large compared to Earth. Most moons in the solar system are tiny compared to their parent planets, but our moon is more than a quarter the diameter of Earth. Scientists think it formed from a colossal impact early in Earth's history, when a Mars-sized object crashed into the young Earth and sent enormous amounts of material blasting into orbit. That material coalesced into the moon, and ever since, the moon has been Earth's companion, orbiting at just the right distance to appear almost exactly the same size as the sun in our sky, making total solar eclipses possible. Those moments when day turns briefly to night, and we see the sun's corona blazing around the dark circle of the moon. The moon pulls at Earth's oceans, creating tides. It stabilizes Earth's axial tilt, preventing wild climate swings. Before the moon, Earth's days were just 5 hours long. The moon's gravitational interaction has gradually slowed Earth's rotation, stretching our days to 24 hours, and the moon continues to drift slowly away from us, about 3.8 centimeters per year. Billions of years from now, if anyone is still here to see it, the moon will appear smaller in the sky, and total solar eclipses will become impossible. But tonight, the moon is still close. Tonight, it might be shining through your window or hanging somewhere in the night sky over your part of the world, reflecting sunlight down to you, a gentle silver light that humans have looked up at for hundreds of thousands of years. You're safe here on Earth. You're held by gravity, surrounded by air, part of an unbroken chain of life stretching back nearly 4 billion years. Let that sink in. Let yourself rest in that knowledge. Beyond Earth, we cross the asteroid belt, a region of rocky debris between Mars and Jupiter. Millions of asteroids orbit here, ranging from dust-sized grains to Ceres, a dwarf planet nearly 600 miles across. These are the leftover building blocks of planets, pieces that never quite came together because Jupiter's gravity stirred the region too violently for a planet to form. If you could gather all the asteroids in the belt together, they would make a body smaller than our moon. Space is vast, and even the asteroid belt is mostly empty. And then we reach the giant, the king of planets, the world that dominates the outer solar system. Jupiter is more massive than all the other planets combined. You could fit 11 Earths side by side across Jupiter's diameter, and more than 1,300 Earths inside its volume. Jupiter is so large that it doesn't actually orbit the Sun in the way you might imagine. The center of mass between Jupiter and the Sun, the point they both orbit around, lies just above the Sun's surface. In a way, Jupiter and the Sun dance together, two partners spinning around a shared point. Jupiter is a gas giant, meaning it has no solid surface to stand on. If you could somehow descend into Jupiter's atmosphere, you would fall through layers of hydrogen and helium, through clouds of ammonia and water vapor, deeper and deeper as the pressure and temperature increased. Eventually, the hydrogen would become so compressed that it would turn into a liquid, and deeper still, it would become metallic hydrogen, a strange state of matter that conducts electricity. At the very center, there might be a rocky core, a solid heart perhaps 10 to 15 times the mass of Earth, but no one knows for certain. Jupiter's most famous feature is the Great Red Spot, a storm larger than Earth that has been raging for at least 400 years, possibly much longer. It's an anticyclonic storm, a high-pressure system where winds reach speeds of 430 kilometers per hour. The storm has been shrinking over the past century, and no one knows if it will eventually disappear or if it will stabilize at a smaller size. But for now, it endures, a raging eye in Jupiter's turbulent face. Jupiter spins faster than any other planet in the solar system. A day on Jupiter lasts just under 10 hours. This rapid rotation flattens the planet noticeably at the poles and bulges it at the equator. It also drives Jupiter's complex weather systems, creating bands of clouds that circle the planet, light zones and dark belts where winds blow in opposite directions. And Jupiter has moons, so many moons. At last count, more than 90, though many of them are tiny, irregular chunks of rock captured from the asteroid belt. But 4 of Jupiter's moons are worlds in their own right, large enough and interesting enough that Galileo saw them through his primitive telescope in 1610 and realized they orbited Jupiter, not Earth. That observation helped overturn the old idea that everything in the universe circled. The largest of these Galilean moons is Ganymede, bigger than the planet Mercury, the only moon in the solar system known to have its own magnetic field. Then comes Callisto, ancient and heavily cratered, its icy surface recording billions of years of impacts. Io is the most volcanically active body in the solar system, constantly churning with eruptions driven by tidal forces from Jupiter's gravity. And then there's Europa. Europa is slightly smaller than our moon, covered in a shell of water ice that's crisscrossed with reddish-brown cracks and ridges. Beneath that ice, scientists believe there's a global ocean of liquid water, kept warm by tidal heating as Jupiter's gravity flexes and kneads Europa's interior. That ocean might be twice the volume of all of Earth's oceans combined, and where there's liquid water and energy, there might be life. Simple life, perhaps. Microorganisms adapted to the dark, but life nonetheless. Europa is one of the most promising places in the solar system to search for biology beyond Earth. Imagine that. A hidden ocean sealed away beneath miles of ice, warmed by the friction of gravity, orbiting a giant planet in the cold reaches of the solar system. And in that ocean, in the utter darkness, perhaps something lives. You don't need to imagine it all at once. You can let the thought float through your mind like a leaf on a slow stream. Let it drift. Let everything drift. Beyond Jupiter, we find Saturn, the jewel of the solar system, the planet with the rings. Saturn is the second largest planet, another gas giant, similar to Jupiter in many ways, but with a lighter touch, a softer appearance. Saturn's atmosphere is a pale butterscotch color with clouds that form subtle bands and occasional storms. Every 30 years or so, a massive storm called the Great White Spot erupts in Saturn's northern hemisphere, a pale oval that can grow to wrap around the entire planet before fading away. But what makes Saturn unforgettable are its rings. From a distance, they look solid, like a flat disk surrounding the planet. But they're not solid at all. They're made of billions of individual particles, ranging in size from tiny grains to house-sized boulders, all of them chunks of water ice. The rings are incredibly thin. They span more than 280,000 kilometers from edge to edge, but in most places, they're less than 10 meters thick. If you made a scale model of Saturn's rings using a sheet of paper to represent their thickness, the paper would need to be several miles. How did Saturn's rings form? No one knows for certain. They might be the remnants of a moon that was torn apart by Saturn's gravity, or perhaps the leftover material from Saturn's formation that never coalesced into a moon. The rings might be ancient, dating back billions of years, or they might be relatively young, just a few 100 million years old. They won't last forever. Slowly, inexorably, the particles are spiraling inward, raining down onto Saturn's atmosphere. In another 100 million years, the rings might be gone, and Saturn will look like just another gas giant. But tonight, they're still there. Tonight, they catch the sunlight and glow softly in the dark. A cosmic reminder that beauty is often temporary. Saturn has dozens of moons too, each one strange in its own way. Enceladus is a small icy moon that shoots geysers of water vapor from cracks near its south pole, geysers that contain organic molecules and salts, suggesting another hidden ocean beneath the ice. Titan is the second largest moon in the solar system, the only moon with a thick atmosphere, a hazy orange envelope of nitrogen and methane that hides the surface from view. When spacecraft finally pierced that haze, they found lakes and rivers and seas, not of water, but of liquid methane and ethane, a hydrocarbon cycle like Earth's water cycle, but at temperatures cold enough to freeze nitrogen solid. On Titan, it rains methane. Rivers carve channels through icy bedrock. Seas lap against alien shores. And all of this happens under a sky so thick with smog that the sun is just a dim glow in the orange haze. Titan is a moon that feels almost like a planet, a world with weather and geology and chemistry happening in slow, cold motion. Your breathing is slower now, isn't it? Deeper, easier. The journey continues even as you rest. The planets keep spinning. The story keeps flowing. We drift outward to Uranus, a planet tilted on its side. Most planets spin like tops, their axes roughly perpendicular to the plane of their orbits. But Uranus is tilted 98 degrees, rolling around the sun like a ball on its side. This means that Uranus has the most extreme seasons in the solar system. Each pole gets 42 years of continuous sunlight, followed by 42 years of continuous darkness. Imagine a winter night that lasts 4 decades. No one knows why Uranus is tilted this way. The leading theory is that early in its history, Uranus was struck by a massive object, something perhaps twice the mass of Earth, and the impact knocked the planet onto its side. If that's true, it was a collision of almost unimaginable violence, yet Uranus survived, and now it circles the sun in its strange sideways orbit, a pale blue-green sphere wrapped in a thick atmosphere of hydrogen, helium, and methane. Uranus is cold. With an average temperature of minus 200 degrees Celsius, it's one of the coldest planets in the solar system. It has faint rings, discovered only in 1977, and more than 24 moons, most of them named after characters from Shakespeare and Alexander Pope. The largest moons are Miranda, Ariel, Umbriel, Titania, and Oberon, icy worlds that orbit in Uranus's equatorial plane, which means they also orbit in a nearly vertical plane relative to the Sun. Miranda, the smallest of the 5 major moons, is one of the strangest objects in the solar system. Its surface looks like it was assembled from mismatched pieces. There are old, heavily cratered regions next to young, grooved terrain, cliffs that tower 12 miles high, and features that suggest the moon was once shattered and reassembled by its own gravity. Looking at Miranda is like looking at a puzzle where the pieces don't quite fit, and yet somehow they hold together. Uranus doesn't demand your attention the way Jupiter or Saturn does. It's quiet, distant, enigmatic, but it's there, rolling through the dark, carrying its moons and rings and secrets with patient indifference. And then we reach the edge, the last of the major planets, a world of deep blue and raging winds. Neptune is the 8th planet, 30 times farther from the Sun than Earth. At this distance, the Sun appears as just a very bright star, offering little warmth. Yet Neptune radiates more heat than it receives from the Sun, suggesting some internal heat source, perhaps leftover warmth from its formation, or energy released as denser materials slowly sink toward the core. Neptune is a beautiful planet, a rich azure blue caused by methane in its atmosphere, absorbing red light. It has the fastest winds in the solar system, with storms where wind speeds reach 2,000 kilometers per hour, faster than the speed of sound on Earth. One such storm, discovered by Voyager 2 in 1989, was called the Great Dark Spot, similar to Jupiter's Great Red Spot. But when the Hubble Space Telescope looked at Neptune a few years later, the Great Dark Spot had disappeared, replaced by new storms in different parts of the atmosphere. Neptune has a system of faint rings and 14 known moons. The largest moon, Triton, is one of the most intriguing objects in the solar system. Triton orbits Neptune backward, opposite to the planet's rotation, a retrograde orbit that suggests Triton wasn't born here. It's probably a captured Kuiper Belt object, something like Pluto, that wandered too close to Neptune and was snared by the planet's gravity. Triton is cold beyond cold, with surface temperatures around -235 degrees Celsius, making it one of the coldest surfaces in the solar system. Yet Triton is geologically active. It has geysers that erupt nitrogen gas, shooting plumes 5 miles high before the gas freezes and falls back as snow. It has a thin atmosphere, just a whisper of nitrogen, and a surface covered in frozen nitrogen and methane, with a pinkish tint, possibly from organic compounds created by solar radiation. Triton is slowly spiraling inward toward Neptune. Millions of years from now, it will cross the Roche limit, the point where Neptune's tidal forces become stronger than Triton's own gravity, and the moon will be torn apart, shredded into a magnificent ring system that might rival or surpass Saturn's. But that's a distant future. For now, Triton endures, orbiting backward, erupting geysers, a refugee from the outer darkness. Let your mind wander now. Let the images blur and soften. You've traveled so far already, through heat and cold, through storms and silence, through worlds of rock and worlds of ice and worlds of endless gas. You've seen moons that hide oceans and moons that spew volcanoes. You've watched planets spin and rings glitter and winds rage across alien skies. And we're not quite done. There's more to see, but you don't need to hold on to every detail. You can drift. You can let go. Beyond Neptune lies the Kuiper Belt, a vast region of icy bodies stretching from Neptune's orbit outward to 50 astronomical units or more. An astronomical unit, or AU, is the distance from Earth to the Sun, about 93 million miles. The Kuiper Belt is where comets come from, at least the short-period comets, those that swing through the inner solar system every few decades or centuries. And in the Kuiper Belt, we find Pluto. Pluto was discovered in 1930 and considered the ninth planet for 76 years. But as telescopes improved and more Kuiper Belt objects were found, some nearly as large as Pluto, astronomers realized they faced a choice: either accept dozens of planets as more objects were discovered, or redefine what a planet is. In 2006, they chose the latter. Pluto became a dwarf planet, a designation that sparked passionate debates and protests. People loved Pluto. They'd grown up with Pluto as a planet. Reclassifying it felt like a demotion, a loss. But Pluto doesn't care about categories. Pluto is still remarkable. It's a small world, smaller than Earth's moon, but it's not just a ball of ice. When the New Horizons spacecraft flew past Pluto in July 2015, it revealed a world of breathtaking complexity. There were mountains made of water ice rising more than 2 miles high. There was a vast plain called Sputnik Planitia, a heart-shaped region covered in nitrogen ice that seems to be renewed constantly, erasing impact craters and creating a geologically young surface. There were glaciers flowing across the landscape, their motion driven by the slow sublimation and condensation of nitrogen. There were layers of haze in Pluto's thin atmosphere, tinted blue by organic compounds. Pluto has 5 known moons. The largest, Charon, is so big compared to Pluto that the two bodies orbit a point in space between them. They're a binary system, locked in synchronous rotation, so they always show the same face to each. Charon has a dark reddish pole, possibly stained by material escaping from Pluto's atmosphere. The other 4 moons are small and tumble chaotically in their orbits. At Pluto's distance, the Sun is 1,000 times dimmer than it is on Earth. Midday on Pluto is like deep twilight here. Yet even in that cold dimness, Pluto changes. It has seasons as it orbits the Sun every 248 years. When Pluto is closest to the Sun, nitrogen sublimates from the surface, thickening the atmosphere. When Pluto moves farther away, the nitrogen freezes out and falls as snow. There is something deeply moving about Pluto, this small icy world at the edge of the classical solar system, still active, still changing, still surprising us. It reminds us that size isn't everything, that even the smallest worlds can have stories worth telling. Your eyelids are so heavy now. Your body feels weightless, almost floating. That's good. That's exactly right. Beyond Pluto, the Kuiper Belt continues, fading gradually into the scattered disk, and then the Oort cloud, a vast sphere of cometary nuclei that surrounds the solar system like a cosmic shell. The Oort cloud is theoretical, never directly observed, but it must exist to explain where the long-period comets come from, those comets that take thousands or millions of years to complete one orbit. The Oort cloud might extend halfway to the nearest star. It's the edge of the Sun's gravitational dominion, the place where our solar system blurs into interstellar space. And yet, technically, objects in the Oort cloud are still part of our neighborhood, still bound to the Sun, still orbiting that distant point of light. But there are ambassadors that have gone farther. Voyager 1 was launched in September 1977. It flew past Jupiter in March 1979 and Saturn in November 1980. After that, Its mission was essentially complete, but it kept going, climbing outward from the solar system. In August 2012, Voyager 1 crossed the heliopause, the boundary where the solar wind gives way to the interstellar medium. It became the first human-made object to enter interstellar space. Voyager 1 is now more than 14 billion miles from Earth, so far away that a radio signal traveling at the speed of light takes more than 22 hours to make the one-way trip. The spacecraft is powered by a plutonium battery that's slowly decaying. Its instruments are failing one by one, but it's still transmitting, still sending back data about the environment beyond the sun's reach. Someday, probably within the next decade, the power will finally fail, and Voyager 1 will go silent. It will keep moving, coasting through the galaxy for billions of years, an artifact of a curious species that once looked up and wondered what was out. The solar system is home, but it's also just one system among billions in our galaxy, and our galaxy is one among billions in the universe. Every planet, every moon, every asteroid and comet is a chapter in a story that began 4.5 billion years ago when a cloud of gas and dust began to collapse under its own gravity. The center of that cloud became the sun. The remaining material flattened into a disk and gradually clumped together to form planets and moons. For a while, the young solar system was violent. Planets migrated inward and outward, their gravity stirring the debris into a chaos of collisions. Earth was struck by the object that created the moon. Uranus was knocked on its side. The asteroid belt was prevented from forming a planet by Jupiter's disruptive influence. But gradually, things settled. Orbits stabilized. The bombardment slowed. The solar system became the relatively calm place it is today. And then on one small blue planet orbiting in the habitable zone, something extraordinary. Life emerged. Simple at first, just self-replicating molecules in warm water. But life spread and diversified and adapted and evolved. It survived ice ages and asteroid impacts and volcanic catastrophes. It filled the oceans and colonized the land and took to the air. It became algae and ferns and dinosaurs and birds and eventually you. You are the solar system looking at it. You are star stuff contemplating stars. The atoms in your body were forged in stellar furnaces, scattered through space by supernova explosions, gathered into a new star system, incorporated into a planet, and eventually into living organisms. You're part of an unbroken chain of cause and effect, stretching back to the beginning. And tonight, as you rest, the solar system continues its ancient rhythms. Mercury races along its eccentric orbit. Venus turns slowly beneath its thick clouds. Earth spins toward another dawn. Mars dreams of the rivers it once had. Jupiter's great red spot churns. Saturn's rings glitter. Uranus and Neptune drift in the cold outer dark. Pluto tumbles through the Kuiper belt, and the sun, always the sun, burns at the center of it all, holding everything together with its gravity, warming the inner planets with its light. You're safe here. You're part of this cosmic dance. You're held by the same gravity that holds the planets, warmed by the same star that warmed the first single-celled organisms 3.5 billion years ago. Nothing is required of you right now except to rest, to breathe, to let your mind wander where it will. Think of the moon, pulling the tides, stabilizing Earth's wobble, reflecting sunlight down through your window. Think of Jupiter, massive and protective, its gravity sweeping up asteroids that might otherwise threaten the inner planets. Think of Saturn's rings, temporary and beautiful, a reminder that nothing lasts forever, and that makes the present moment precious. Think of Europa's hidden ocean, Enceladus's geysers, Titan's methane lakes, Triton's nitrogen snow. Think of all the spacecraft we've sent out there. Voyager 1 and 2, now in interstellar space. Pioneer 10 and 11 also leaving the solar system, but long since silent. New Horizons, which flew past Pluto and is now speeding toward the Kuiper Belt. Cassini, which orbited Saturn for 13 years before deliberately plunging into the planet's atmosphere in 2017. Juno, currently orbiting Jupiter, studying its atmosphere and magnetic field. The Mars rovers, Curiosity and Perseverance, slowly making their way across the Martian surface, drilling into rocks, searching for signs of ancient life. We've touched these worlds. We've sent machines to orbit them, to land on them, to study them up close. We've extended our senses across millions and billions of miles. And we've learned that the solar system is even more wondrous than we imagined. Every new mission reveals new mysteries. Every answer raises new questions. But you don't need to solve the mysteries tonight. You don't need to understand everything. It's enough to know that the universe is vast and strange and beautiful, that we're part of it, and that right now, in this moment, you can rest. Let your thoughts become like clouds drifting across a calm sky. Let them come and go without holding on to them. Maybe you're thinking about Jupiter's moons, or Saturn's rings, or the frozen surface of Pluto. Maybe you're thinking about something else entirely, something from your day, or your life. That's fine. Let the thoughts drift. Let them soften and blur at the edges. Your body knows how to sleep. You've done it thousands of times. Your breathing will slow, your heartbeat will calm, your muscles will relax, and gradually, imperceptibly, you'll cross the threshold between waking and sleeping. You might not notice when it happens. You might drift back and forth a few times. That's normal. That's how sleep comes, gently, in its own time. Think of Earth spinning through space at 1,000 miles per hour, orbiting the sun at 67,000 miles per hour, and yet you feel none of that motion. You're held safely by gravity, moving with the planet, part of its journey through the cosmos. You're on a spaceship, really. A beautiful, life-filled spaceship with oceans and forests and mountains and deserts, all of it hurtling through the void together. And at night, when the side of Earth you're on turns away from the sun, you see the other members of the solar system. You see Venus and Mars and Jupiter and Saturn, bright wanderers against the fixed stars. Ancient humans saw these same planets and called them gods. They tracked their movements across the sky and wove stories about them. We've lost some of that wonder in modern times with our light pollution and our screens. But the planets are still there, still moving along their orbits, still shining with reflected sunlight. Maybe tomorrow night or sometime soon you'll look up and try to spot. Venus is easy to find, the brightest object in the evening or morning sky. Jupiter is bright too, a steady white light that doesn't twinkle like stars do. Saturn is fainter but still visible, a yellowish point of light. Mars has a distinct reddish tint. With binoculars, you can see Jupiter's 4 largest moons as tiny points of light flanking the planet. With a small telescope, you can see Saturn's rings. But tonight, you don't need to look up. Tonight, you can close your eyes and see the planets in your mind's eye, each one a world, each one a story, each one part of the magnificent system we call home. The sun will rise again tomorrow. Earth will keep spinning. The moon will continue its slow drift away from us a few centimeters per year, patient and inevitable. The seasons will change as Earth's tilted axis carries each hemisphere toward and away from the sun. Spring will come, and summer and autumn and winter, and spring again, a rhythm as old as the planet itself. And you'll be here for some of those seasons. You'll see more sunrises and more sunsets. You'll look up at the moon in its different phases. You'll wish on stars that are actually planets. You'll live your life on this small blue world, and that's a gift beyond measure. There are moments when the solar system reveals itself in unexpected ways. During a solar eclipse, when the moon passes directly between Earth and the sun, the sky darkens in the middle of the day. Birds go silent, thinking night has come. The temperature drops. And if you're lucky enough to be in the path of totality, you see the sun's corona. That outer atmosphere, usually invisible in the sun's glare, suddenly blazing around the moon's dark circle like a crown of white fire. For a few precious minutes, you're standing in the moon's shadow, cast across the earth from 250,000 miles away. Or during a meteor shower, when Earth passes through the debris trail left by a comet, and tiny particles, most no larger than grains of sand, strike the atmosphere at tens of thousands of miles per hour. They vaporize in a flash of light, and from the ground you see shooting stars streaking across the Perseids in August, the Geminids in December, the Leonids in November. Each shower comes from a different comet. Particles spread along the comet's orbit, and Earth passes through that orbit once a year like clockwork. Or on a clear, dark night away from city lights, when you look up and see the Milky Way, that river of light flowing across the sky, looking at our own galaxy from the inside, seeing the combined glow of billions of stars. And somewhere in that vastness, about 26,000 light years from here, at the center of the galaxy, there's a supermassive black hole millions of times the mass of the sun. You can't see it directly, but it's there, and everything in the galaxy, including our solar system, orbits around it. The sun takes about 200 million years to complete one galactic orbit. The last time we were at this point in the galaxy, dinosaurs were just beginning to diversify on Earth. The scales are so vast, they become almost meaningless. 200 million years, 26,000 light years, billions of stars. It's too much to hold in your mind all at once. But you don't need to hold it. You can just let it wash over you, a gentle reminder of how big everything is and how small, and how it all fits together in ways we're only beginning to understand. Your breathing is so slow, each breath like a wave on a quiet shore, rising and falling. Let's come back to the planets for a moment. Let's visit them one more time, but gently, briefly, like saying goodnight to old Mercury, closest to the Sun, racing through its orbit, days longer than years, ice hiding in permanent shadow. Mercury endures, Mercury survives. Venus, shrouded in clouds, surface hot enough to melt metal, winds screaming in the upper atmosphere. Venus is beautiful and deadly, a reminder that appearances can deceive. Earth, our home, the only world we know for certain, has life. Oceans and forests and deserts and ice, spinning through space, held together by gravity and time. Earth is fragile and resilient, ancient and ever-changing. The moon, Earth's companion, scarred by billions of years of impacts, pulling at our tides, stabilizing our seasons, drifting slowly away, but still close enough to eclipse the sun. The moon is patient. The moon endures. The moon has been humanity's companion for as long as humans have existed, and long before that. It's been pulling at Earth's oceans, creating tides that rise and fall twice each day, a rhythm so steady that countless species have adapted their lives to it. Crabs emerge to feed when the tide goes out. Corals release their eggs and sperm in synchronized spawning events, timed to the full moon. Sea turtles return to the beaches where they were born, arriving with the high tides of the new moon. Ancient humans watched the moon change shape, waxing from new to full and then waning back to darkness, completing the cycle in roughly 29.5 days. They didn't understand why it changed, but they recognized the pattern, and they used it to mark time. The word month comes from moon. Many calendars throughout history have been lunar calendars, organized around the moon's phases rather than Earth's orbit around the sun. The moon appears to glow, but it produces no light of its own. Every bit of moonlight is reflected sunlight, bounced off the moon's gray surface and sent toward Earth. When the moon is full, it's because the sun, Earth, and moon are aligned with Earth in the middle, so we see the entire sunlit half of the moon. When the moon is new, the alignment places the moon between Earth and sun, so the sunlit side faces away from us and we see only darkness. The phases in between, the crescents and quarters, show us the moon's surface lit from different angles as it orbits Earth. The moon's surface is covered in craters, each one marking an ancient impact. Early in the solar system's history, when the planets were still forming, the inner solar system was crowded with debris. Asteroids and comets constantly bombarded the young worlds. Earth was hit just as often as the moon, but Earth has weather and tectonics, processes that erase craters over time. The moon has neither. The moon's craters are forever, or as close to forever as anything gets in this universe. The largest craters, the ones you can see with your naked eye as dark patches, are called Maria, Latin for sea, because early astronomers thought they might be bodies of water. They're not. They're vast plains of solidified lava, formed when massive impacts cracked the moon's crust and magma welled up to fill the basins. Some of those craters are billions of years old. When you look up at the moon, you're seeing a surface that has remained largely unchanged since complex life first appeared on Earth. The moon remembers a time when our planet was covered in single-celled organisms, when the continents were arranged in configurations that wouldn't be recognized today, when the atmosphere had far less oxygen. The moon has witnessed all of Earth's history, always turning the same face toward us because of tidal locking. That gravitational dance that synchronized the moon's rotation. 12 humans have walked on that. 12 men, all Americans, all between 1969 and 1972. They left footprints that will remain visible for millions of years because there's no wind or rain to erase them. They left flags and equipment, and in a few cases, small mementos. They collected 842 pounds of moon rocks and brought them back to Earth, where scientists have been studying them ever since, learning about the moon's formation and history, confirming theories, and discovering new mysteries. Those astronauts described the moon's surface as desolate but beautiful. Gray dust as fine as talcum powder, studded with rocks and boulders. Hills and mountains rising in the distance, their peaks catching the sunlight. And above it all, utterly black even during the day because there's no atmosphere to scatter light. And in that black sky, Earth, hanging like a blue and white ornament 4 times larger than the moon appears from Earth, swirled with clouds, patched with the browns and greens of From the moon, you can see Earth rotate. You can watch weather systems move across You can see city lights on the night side, evidence of civilization, of billions of humans living their lives, unaware or barely aware that someone is watching from 250,000 miles away. The astronauts said it was overwhelming, seeing Earth like that, so small and fragile, so clearly finite. They said it made their problems, the things they'd worried about before the mission, seem trivial. They said it gave them a profound sense of connection to every other person on the planet. That feeling has a name now: the overview effect. It's the cognitive shift that happens when you see Earth from space, when you realize viscerally, not just intellectually, that we're all on this one planet together, that borders and nations are human inventions, that the atmosphere is a thin and precious thing, that everything we've ever known exists on that small blue sphere. You don't need to go to space to feel something similar. You can feel it by looking up at the moon and thinking about the fact that humans have been there, that we've touched another world. You can feel it by imagining the view from the moon, Earth rising over the lunar horizon, achingly beautiful against the infinite black. You can feel it by considering the distances, the emptiness, the improbability of life, the sheer luck of being here. Let your breathing deepen. Let your muscles soften. The moon is out there right now, somewhere in the sky or below the horizon, continuing its orbit, pulling the tides, reflecting the sun. You're connected to it through gravity, through shared history, through the simple fact of looking up and wondering. There are other moons in the solar system, many moons, each one different. Jupiter has at least 95 moons, though the count keeps changing as astronomers discover more tiny captured asteroids in distant orbits. Saturn has over 140. Uranus has 27. Neptune has 14. Even Mars has 2 small moons, Phobos and Deimos, irregularly shaped chunks of rock that look more like asteroids than proper moons, and indeed they probably are, snagged by Mars's gravity long ago. But most of these moons are small and unremarkable. The interesting ones are the large moons, the ones big enough to be round. massive enough to have their own geology, complex enough to... Io, orbiting Jupiter, is the most volcanically active body in the solar system. Its surface is constantly renewed by eruptions, making it one of the youngest surfaces anywhere. Io is caught in a gravitational tug-of-war between Jupiter and the other large moons, Europa and Ganymede. Their combined pull flexes Io's interior, generating friction, creating heat, melting rock. The result is spectacular. Plumes of sulfur and sulfur dioxide shooting hundreds of kilometers into space. Lava flows covering the surface. Volcanic mountains rising taller than Everest. Io is yellow and orange and red, colored by sulfur compounds, almost like a peach, which is actually the nickname scientists gave it when Voyager first photographed it up close. Europa, by contrast, is white and smooth, covered in water ice, crisscrossed with reddish-brown streaks. The streaks are cracks in the ice, places where the crust has fractured and material from below has welled up. Europa's surface is young too, but not because of volcanism. The ice is constantly renewed by the liquid ocean beneath, an ocean kept warm by the same tidal heating that powers Io's volcanoes, though to a lesser degree. Europa's ocean might be 60 miles deep, twice as deep as Earth's deepest ocean. It contains more water than all of Earth's oceans combined. And where there's liquid water, where there's energy, where there are chemical gradients, there might be life. Scientists have proposed missions to Europa, orbiters that would study the moon in detail, landers that might sample the ice, even submarines that could one day drill through the crust and explore the ocean directly. That last idea is still science fiction, decades away at least. But the fact that we're seriously discussing it shows how far we've come. A century ago, we didn't even know there were other solar systems. Now we're planning to search for life in the ocean of a moon orbiting another planet. Ganymede, the largest moon in the solar system, is bigger than Mercury. It has its own magnetic field, the only moon known to have one, generated by a liquid iron core deep inside. Ganymede's surface is a mix of old dark terrain, heavily cratered, and younger bright terrain, grooved and ridged, evidence of tectonic activity in the... Ganymede might have an ocean too, buried beneath many miles of ice, but it's less accessible than Europa's, less promising as a target for life. Callisto is the outermost of Jupiter's large moons, and it's ancient. Its surface is saturated with craters, so many that new impacts mostly just hit old craters, erasing one scar to create another. Callisto seems to be a frozen relic, a moon that froze early and stayed frozen, preserving a record of the heavy bombardment that shaped the solar system billions of years ago. There's beauty in that too, in the persistence of memory, in the scars that refuse to fade. Saturn's largest moon, Titan, is in a category by itself. It's the only moon with a thick atmosphere, and that atmosphere is mostly nitrogen, just like Earth's, though without the oxygen. The pressure at Titan's surface is about 1.5 times Earth's sea level pressure. You could walk on Titan without a pressure suit, though you'd need to bundle up against the cold, minus 179 degrees Celsius, and you'd need to bring oxygen to breathe. Titan's atmosphere is hazy, a thick orange smog made of complex organic molecules created when ultraviolet light from the sun breaks apart methane and nitrogen molecules, allowing them to recombine in new ways. These organic molecules, called tholins, drift down to the surface like snow, covering everything in a reddish-brown layer. When Cassini dropped the Huygens probe onto Titan's surface in 2005, it took pictures on the way down and after landing. The images showed a landscape that looked eerily familiar: river channels, shorelines, smooth plains, rounded boulders. But the boulders were made of water ice, hard as rock at those temperatures, and the rivers and lakes were filled with liquid methane and ethane. Titan has weather. Methane evaporates from the lakes, rises into the atmosphere, forms clouds, and eventually falls as rain. The rain carves channels and forms rivers that flow into the lakes, and it's a complete hydrological cycle, just like Earth's, but with methane instead of water. Titan has seasons too, as Saturn's tilt carries each hemisphere toward and away from the Sun over the course of Saturn's 29-year orbit. The seasons affect where the methane concentrates, causing the lakes to grow and shrink, changing the landscape gradually over decades. Scientists think Titan might have a liquid water ocean too, buried deep beneath the icy crust, just like Europa and Ganymede. So Titan has two environments where life might exist: the frigid hydrocarbon lakes on the surface, where life would have to be radically different from anything on Earth, and the warmer water ocean below, where life might be more familiar. Either way, Titan is one of the most intriguing places in the solar system. Enceladus is much smaller than Titan, but it's also fascinating. Voyager first photographed Enceladus in the 1980s and saw a bright reflective surface, the brightest in the solar system, whiter than fresh snow. Enceladus reflects nearly 100% of the sunlight that hits it. That should have been the end of the story, a small icy moon with a bright. But when Cassini arrived at Saturn in 2004, it discovered something extraordinary: plumes of water vapor and ice crystals erupting from cracks near Enceladus's south pole. These plumes shoot hundreds of kilometers into space. Some of the material escapes Enceladus's weak gravity and becomes part of Saturn's E-ring, a faint ring made of tiny ice particles supplied continuously by Enceladus. But most of the material falls back to the surface as snow, which explains why Enceladus is so bright. The surface is constantly renewed. Cassini flew through the plumes several times, analyzing their composition. The plumes contain water vapor, ice grains, salt, silica, and organic molecules. The salt and silica suggest the water is coming from an ocean in contact with a rocky core, where minerals dissolve into the water. The organic molecules suggest chemistry is happening, complex reactions that might be a precursor to life or might even support life directly. Enceladus is tiny, barely 300 miles across, small enough to fit inside the state of Texas. Yet it has an ocean, it has chemistry, it has energy from tidal heating, and it's spraying samples of that ocean directly into space where we can analyze them without even landing. It's a gift to science, an accessible window into a hidden ocean world. These moons, Europa and Enceladus especially, have changed how we think about life in the solar system. we used to assume that life required sunlight, that photosynthesis was the foundation of any ecosystem. But in the late 1970s, scientists discovered deep-sea hydrothermal vents on Earth, hot springs on the ocean floor where superheated water rich in minerals erupts from cracks in the crust. These vents support thriving ecosystems based not on sunlight but on chemosynthesis, where bacteria extract energy from chemicals like hydrogen sulfide. There are tube worms and clams and crabs and fish, all living in total darkness, all fed ultimately by chemical energy from Earth's interior. If life can exist at hydrothermal vents on Earth, it might exist in the oceans of Europa or Enceladus, where tidal heating could power similar vents. The life would probably be simple, single-celled organisms, bacteria or archaea, nothing you'd recognize as complex or intelligent. But it would be life. It would be a second genesis, proof that life can arise independently, that Earth isn't unique, that the universe might be teeming with simple organisms wherever conditions allow. We don't know yet. We haven't found life on Europa or Enceladus or anywhere else beyond Earth. But we're looking. Missions are being planned. Instruments are being designed. Someday, maybe within your lifetime, we might have an answer. And if we find life, even microbial life, it will change everything. It will tell us that life isn't a fluke, that it's a natural consequence of chemistry and energy and liquid water. It will suggest that the universe is full of life, that countless worlds scattered across countless solar systems have their own organisms, their own ecosystems, their own evolutionary histories. We might still be alone as an intelligent, technological species. The distances are so vast, and civilizations might be so rare or so short-lived. But we wouldn't be alone as living beings. We'd be part of a cosmic community of life, connected not by communication or travel, but by shared chemistry, shared origins in the same fundamental laws of physics and chemistry. Let that thought settle over you like a soft blanket. You're resting here on Earth, but you're connected to all these moons, all these worlds, through the same elements, the same forces, the same story. The water in your body came from comets and asteroids delivered to Earth billions of years ago. The same process might have delivered water to Europa and Enceladus. The organic molecules in your cells might resemble the organic molecules raining down on Titan. The energy that powers your metabolism comes ultimately from the sun, but it's the same kind of energy, chemical energy, released through reactions that powers life at hydrothermal vents and might power life in hidden oceans. You're not separate from the solar system. You're part of it. You're made of it. And as you rest, as your breathing slows and your thoughts drift, you can imagine yourself floating out there, visiting these moons, seeing their surfaces up close, marveling at their strangeness and beauty. Imagine standing on Europa, looking up at Jupiter, dominating the sky. 12 times larger than the moon appears from Earth, banded with clouds, a swirling giant that never sets because Europa is tidally locked, always showing the same face to Jupiter. Imagine feeling the ice beneath your feet, knowing there's an ocean below, an entire world of liquid water, dark and deep and mysterious. Imagine standing on Titan, looking through the orange haze, seeing the shoreline of Kraken Mare, the largest of Titan's methane seas stretching to the horizon. Imagine watching waves lap against the icy beach, driven by winds in that thick atmosphere. Imagine the rain falling, not water, but methane, cold and strange, pattering on your spacesuit like a familiar sound in an alien place. Imagine standing on Enceladus near the South Pole, watching the geysers erupt, plumes of ice crystals catching the distant sunlight, glittering like diamonds as they arc into the black sky and fall back. Imagine knowing that water came from an ocean, that it's been in contact with rock, that it contains salts and organics, that it's the closest thing we've found to a potential habitat for life beyond Earth. These aren't fantasies. These are real places. Spacecraft have been there. Cameras have photographed them. Instruments have measured them. Humans haven't visited yet, but machines have, and someday, perhaps, humans will follow. Someday there might be bases on the Moon, settlements on Mars, research stations on Europa or Titan. Someday humans might be scattered throughout the solar system, adapted to low gravity and radiation, living in habitats beneath the ice or inside rotating cylinders, looking back at Earth as one world among many. But that's the future. Tonight is about now, about resting here on Earth, about appreciating what we have and what we've learned, about letting the wonder of it all wash over you without needing to understand every detail or remember every fact. Your body is so relaxed now. Your mind is quiet, thoughts drifting like barely forming before that's exactly right. You're on the edge of sleep, that liminal space where you're not quite awake and not quite dreaming, where the boundary between yourself and the universe feels thin and permeable. The moons are still there, orbiting their planets, reflecting sunlight, hiding their secret. The planets are still there, spinning and orbiting, following the same paths they've followed for billions of years. The sun is still there, burning steadily, converting hydrogen to helium, radiating light and warmth into the void. And you're still here, held by Earth's gravity, breathing Earth's air, part of Earth's biosphere, connected to everything. Rest now. Let the solar system cradle you. Let the vastness hold you. Let the ancient light of distant worlds illuminate your dreams. You're safe. You're home. And tomorrow, when you wake, the universe will still be here, still vast, still beautiful, still full of mysteries waiting to be explored. Mars, the red planet, cold and dry now, but once warm and wet. Rivers carving valleys, lakes filling craters, perhaps life stirring in those ancient waters. Mars remembers. Mars dreams. The asteroid belt, millions of rocky fragments, the pieces that never became a planet, orbiting in the space between Mars and Jupiter. Each asteroid a world in miniature, each one with its own shape and composition and story. Jupiter the giant, the king, more massive than all other planets combined, with storms that rage for centuries, and moons that hide oceans beneath ice. Jupiter's power and mystery, grandeur and violence. Saturn, the jewel, with its magnificent rings of ice and rock, and Titan with its methane lakes, and Enceladus with its geysers spraying water into space. Saturn is beauty and strangeness, elegance and complexity. Uranus, tilted on its side, rolling around the sun, seasons lasting decades, a pale blue-green sphere wrapped in mystery. Uranus is the outsider, the rebel, forever changed by some ancient catastrophe. Neptune, the farthest giant, deep blue and windswept, with Triton orbiting backward, a captured moon slowly spiraling toward destruction. Neptune is the edge of the familiar, the last of the classical planets. And Pluto, small and distant and resilient, with mountains and glaciers and a heart-shaped plain, reclassified but not diminished, still surprising us with its complexity. Pluto is a reminder that even the smallest voices deserve to be heard. Beyond Pluto, the Kuiper Belt stretches into darkness, and beyond that, the scattered disk, and beyond that, the Oort cloud, and beyond that, the space between stars, vast and cold and mostly empty, but not entirely. There are rogue planets out there, worlds ejected from their home systems, wandering the galaxy alone. There are brown dwarfs, failed stars not quite massive enough to ignite fusion. There are clouds of gas and dust, the raw material for new stars and new planets. And there are the Voyager spacecraft and the Pioneers and New Horizons, all of them leaving the solar system, carrying pieces of human culture with them. Voyager 1 and 2 each carry a golden record, a time capsule with sounds and images from Earth, music and greetings in different languages, pictures of humans and animals and landscapes, instructions for how to play the record, written in what we hope is a universal language of mathematics and physics. The chances that any alien civilization will ever find these records are vanishingly small. Space is so vast, and the spacecraft are so tiny. But we sent them anyway, because it felt important to try, to reach out, to say we were here, we existed. We wondered what else was out there. And maybe billions of years from now, long after the sun has become a red giant and swallowed the inner planets, long after Earth itself has been destroyed, those golden records will still be out there, drifting through the galaxy, silent ambassadors from a world that once was. But that's the distant future. That's not something you need to think about tonight. Tonight is about the present, about the solar system as it is now, about the quiet beauty of planets spinning in the dark, about the privilege of being alive on a world where you can look up and wonder. There's a concept in astronomy called the cosmic calendar, where the entire history of the universe is compressed into a single year. If the Big Bang happened on January 1st, then the Milky Way galaxy formed in March. Our solar system formed in September. Life on Earth appeared in late September. Complex multicellular life didn't emerge until mid-November. Dinosaurs ruled the Earth from December 25th to December 30th. All of human history, everything we've ever done, every civilization that's ever risen and fallen, all of it fits into the last minute of December 31st. On that scale, your entire lifetime is a fraction of a second, a single breath, a heartbeat. And yet, in that fraction of a second, you contain multitudes. You have memories and dreams and hopes. You've loved people and been loved. You've seen sunrises and tasted food and heard music and felt rain on your skin. You've laughed and cried and wondered and learned. You've looked up at the night sky and felt something, some connection to the vastness, some sense that you're part of something larger than yourself. You are. You're part of the solar system, part of the galaxy, part of the universe. You're made of atoms forged in the hearts of dying stars. You're standing on a planet that's been orbiting the sun for 4.5 billion years. You're breathing oxygen produced by plants and algae that have been photosynthesizing for billions of years. You're part of an unbroken chain of life stretching back to the very first cell. And right now, in this moment, you can rest. You can let go of whatever you've been carrying. You can release the tension in your shoulders, the thoughts circling in your mind, the worries about tomorrow. None of it needs your attention right now. The planets will keep spinning. The sun will keep shining. The universe will continue its slow evolution from order to entropy and back again. Your only job right now is to breathe, to rest, to let sleep come in its own time. Think of the astronauts who've looked back at Earth from space. They talk about seeing the planet as a whole, a blue marble against the black, with no visible borders, no evidence of the divisions we create down here. They talk about how fragile it looks, how thin the atmosphere is, how precious and unlikely this oasis of life seems in the vast, sterile cosmos. That perspective, seeing Earth from the outside, it changes something. It makes the petty concerns feel smaller. It makes the shared humanity feel larger. It reminds us that we're all on this planet together, all breathing the same air, all warmed by the same sun, all protected by the same magnetic field and the same ozone layer and the same blanket of atmosphere. And tonight, as you drift toward sleep, you can carry that perspective with you. You can imagine yourself floating above the earth, looking down at the clouds and the continents and the oceans, seeing the Terminator line where day meets night, watching the sunrise spread across the planet, a wave of light chasing away the darkness. You can imagine the earth spinning beneath you, carrying you through space at 1,000 miles per hour. You can imagine the moon rising over the horizon, gray and cratered and beautiful. You can imagine the sun beyond, so bright you can't look directly at it, a sphere of nuclear fusion 93 million miles away. And beyond the sun, you can imagine the other planets, each in its own orbit, each at its own distance, all of them moving together in the same direction, all of them part of the same, all of them born from the same cloud of dust and gas 4.5 billion years ago. Mercury, Venus, Earth, Mars. The rocky planets, the terrestrial worlds, each with its own geology and history. Jupiter, Saturn, Uranus, Neptune, the giants, the gas and ice worlds, each with its retinue of moons, each a miniature solar system unto itself. And beyond Neptune, the Kuiper belt and the scattered disk and the Oort cloud stretching out into the darkness, gradually fading into interstellar space. This is your neighborhood. This is your corner of the universe, and it's magnificent. Let that magnificence fill you. Let it lift you. Let it carry you gently into dreams. You're safe. You're held. You're part of something ancient and ongoing and vast beyond comprehension. The same forces that hold planets in their orbits are holding you to this planet. The same light that illuminates Jupiter and Saturn has touched your face. The same atoms that make up distant moons are cycling through your body right now. There's no separation between you and the cosmos. You're not observing it from the outside. You're part of it, woven into the fabric of space and time, connected to everything that has ever been and everything that ever will be. And with that knowledge, with that sense of connection and belonging, you can let go. You can release your grip on the day, on the thoughts, on the need to stay awake. You can trust that sleep will find you, that morning will come, that the earth will keep spinning and the sun will keep shining and the solar system will continue its ancient dance. Rest now, dear friend. Rest and dream. Dream of planets and moons and rings of ice. Dream of storms that last for centuries and oceans hidden beneath frozen crusts. Dream of spacecraft sailing through the dark, carrying messages from humanity to the stars. Dream of Earth, your home, this precious blue world in the vast Black Sea. Dream of its forests and mountains, its rivers and deserts, its cities glowing in the night. Dream of all the life here, the incredible diversity, the millions of species sharing this one planet, each one adapted to its own niche, each one part of the great web of life. Dream of the sun rising tomorrow, painting the sky in shades of gold and pink and orange. Dream of another day, another chance to be alive, to breathe, to see, to feel, to wonder. But that's tomorrow. Tonight is for rest. Tonight is for letting the universe hold you. Tonight is for surrendering to the gentle pull of dreams, to the quiet darkness behind your eyelids, to the soft rhythm of your own breathing. The planets will be there when you wake. They're not going anywhere. They'll still be orbiting the sun, still reflecting its light, still carrying their secrets and their stories. And you'll still be here, on Earth, part of this magnificent solar system, part of this ongoing miracle of existence. So rest. Let your body relax completely. Let your mind drift and wander and eventually grow quiet. Let sleep wrap around you like a warm blanket, like the atmosphere wraps around the earth, holding you close, keeping you safe. The solar system is vast, but you are here, and here is exactly where you need to be. You're in the right place at the right time, doing the right thing, which is simply resting, simply being, simply allowing yourself this moment of peace. And as you drift deeper into sleep, as the boundary between waking and dreaming becomes soft and permeable, carry with you this one last thought. You are made of star stuff, and the stars are made of the same matter as you. You are the universe experiencing itself, the cosmos looking back at itself, the solar system becoming aware of its own existence. That's not poetry. That's physics. That's the literal truth. And it's beautiful. Sleep well, dear friend. Sleep deeply and peacefully. The planets are watching over you. The moon is pulling the tides. The sun is waiting patiently beyond the horizon. And you are exactly where you belong, resting here on Earth, breathing this air, existing in this moment, part of the eternal dance of matter and energy and time. Let yourself go now. Let sleep take you. Let the solar system cradle you into dreams. You are safe. You are held. You are home.